Okay, so for this week, we're going to be looking at Chapter 6, which is on global climate systems. The thought here is, and the concept that we want you to learn is that different regions of the world can have the same climate, and scientists have classified those climates based on varying characteristics, mostly temperature and precipitation. And that allows us then to compare and contrast climates across the surface of the Earth. So we're going to go through those, and there'll be some climagraphs, which shows the relationship, the monthly relationship between temperature and the amount of precipitation on average per month over the course of a year. The book goes into these concepts as well, so pay very close attention. There's nothing in the study area, no videos to watch, but you want to pay attention, especially to the map of the Köppen climate classification, so you know where these various climates are. Okay, so off the bat, one thing that's kind of cool to look at on this very first slide is that I don't know if you know what we're looking at, but you can see the snow here, but this is a desert in the mountains, and this is in China. This is the Taklamakan Desert in China, and so these are the surrounding high elevation mountains with the snow. This is the desert down in the center, and you can see that as some of the snow melts, the water flows downstream, and you actually get like a river that goes through there, and you can see the vegetation there. So when people live here, and they're going to live in these areas where there's water and vegetation. But just an example of how climates can vary across the surface of the earth, where you can get a very arid, dry climate. We tend to think of deserts as hot, but they're not always hot. The Arctic and Antarctic are deserts just because there's no moisture there. They're so dry. Okay, so two terms you need to know. Weather, that's like a snapshot of the climatic conditions at a given moment in time. When you listen to the weather on the radio or watch it on the news, that's what you're getting. You're getting the weather for that exact moment in time. Climate, on the other hand, is a pattern that emerges over time, where we've taken the weather over many days, over many weeks, months, years, hundreds of years, and that will give us a pattern, and we can look at that, and that helps us predict what's going to happen in the future. And we'll get into that next week with Chapter 7 when we look at climate change. Now, for the study of climate is what we call climatology, where you analyze long-term weather and patterns over space and time, and that gives you some idea of the diverse climatic conditions on the surface of the Earth. So we can take the broad similarities, the similar characteristics that exist in regions, and then group those into these climatic regions that we're going to be looking at. Okay? So again, climate is this weather of some locality that's averaged over some period of time. Okay, and so you can look at it quantitatively in terms of what we call the normal, and the means, and the average, and then the extremes, the highs and the lows. You have to remember too, there's the high and the low. The difference between those is what we call the range. So if the high is 80 and the low is 30, 30 from 80 is 50. That's the temperature range. We also take into account wind and some other things as well. In the United States, the outfit that does this is NOAA, NOAA, and part of the National Oceanic and Atmospheric Association Agency. I'm sorry, National Oceanic and Atmospheric Agency, and part of their organization is the NCDC, the National Climatic Data Center, and they collect all this weather data and make it available for users like you. Okay, so in America, Death Valley, that's the hottest and driest place in America. And in 1913, it got down to, or up to, I should say, 134 degrees Fahrenheit. And it says it's the second highest temperature, but they've actually gone back and they think it is now. It actually was the highest temperature ever recorded on Earth. In 1896, it had over 40 successive days of over 120 and 105 successive days over 110. And why does that happen? Well, because of its topographic setting. It's a valley and mountains, traps the hot air in there. We'll get into that in a couple weeks when we look at tectonic landforms and so forth. This is just an example of this. So most of you probably don't remember this, but back in 1997-98 was an El Nino year. So Death Valley, that's Death Valley, got a lot of rain. And so you can see all the wildflowers here that sprouted up. Now you go a few years later in the same location, and this is what it looked like in 2002. And by then it had very little rain. And so you can see the difference there between this and this. Now, what we have are climate boundary conditions, and that's the conditions that create these different climate regions. And these are the things that influence that. Latitude is the main one. The further away we get from the equator, the colder the temperature. Elevation, the higher up you are, the lower the temperature. The topography, whether it's flat or mountainous, for example. Proximity to large bodies of water, because remember in previous chapters, water can hold lots of heat energy, so it moderates the temperature. If you're in the middle of a continent, you have a much wider temperature range with colder colds and warmer warms. Okay? And the circulation of the winds and the water in the ocean all play a role in this as well. And so what interacts to produce the climate? Insolation, again, the sun's energy, that's again varies by latitude. The higher up we go in latitude, the less insolation we get. The energy balance, the global circulation of energy, the temperature, which is related to all these things. Air masses, remember we looked at this, the air masses that influence the United States, the two polars and the two tropicals, and then air pressure, of course. And then atmospheric moisture and precipitation. So all of these, when you combine them, all these variables together, that's what creates our climate. Okay, so let me stop here and then we'll get into climate classification in part 2 of our lecture.